Hey guys, welcome to question MM387 of the Maths Methods Fortifier study guide. So, in this question we've got a gym that has 2,000 members. They run a monthly survey to find out the health habits of their members, and in last month's survey it was discovered that the probability that any given member drinks more than 2 litres of water each day is 0.35. So probability of greater than 2 litres is 0.35. Now this month 180 people responded to the survey. For this sample size, p hat is the random variable of the distribution of sample proportions of members who drink more than 2 litres of water each day, and the value of probability of p hat is greater than or equal to 1/3, given that p hat is less than or equal to 7 on 18 is. Alright, there's a fair few steps in this, but our very first step, whenever you see something like this, whenever you've got probability of p hat is more than or less than something, or is equal to something, we always want to convert that into an x value, okay? And what I mean by that is we can kind of convert this into a binomial distribution, alright? So p hat is often said to be, or not often said, it is x over n, alright? Where x is your successful number of trials, and n is the total number of trials, right? So if p hat is equal to 1/3, and we're looking for an x value, 1/3 equals x over our n value, which is our total number of survey respondents, which is 180. It's 180 there, which means that our x value is equal to 60, right? So when p hat equals 1/3, x equals 60. And we need to do that for this one as well. So we say that p hat is equal to x over n. 7 on 18 equals x over 180. And we can then say that x is equal to 70. Okay, so these are really important because what that means is that the probability that p hat is greater than or equal to 1/3, given that probability p hat is less than or equal to 7 on 18, is equal to the probability that x is greater than or equal to 60, given that x is less than or equal to 70. Alright? And we're going to use a binomial distribution to make this a lot easier to handle, right? And you'll see what I mean by that in a second. So, as soon as we see this probability of p hat, we want to change it into an x value so that we can use binomial distribution on it. Now, we've got this now, which is really good, because that's what we needed. Now, we treat this as a binomial distribution. Alright, so what I mean by that is we can now use binomial, actually, just even before we do that, I'm just going to rewrite this. So probability that x is greater than or equal to 60, given that x is less than or equal to 70, equals probability that x is greater than or equal to 60 intersect x is less than or equal to 70 over probability is x less than or equal to 70. Right, so that's our general given probability formula or conditional probability formula. So the intersect between greater than or equal to 60 and less than or equal to 70 is between 60 and 70, right? Over probability x is less than or equal to 70. Awesome. So now we need to find the probabilities of each one of these things happening in this particular distribution, right? So if we treat this as a binomial distribution in our binomial CDF calculator in our CAS, it's going to ask us for a few things. We're going to be asked for lower, upper, n, and p. Right? So our lower, in this case, is 60. Our upper is 70. Our n is 180, right? Because we're asking 180 people whether they drink more than 2 litres of water or not. So the reason we can actually create this in a binomial distribution is because, excuse me, people who go to the gym either drink more than 2 litres or they don't. It's a binary option. There's either a success, which means they drink more, or a failure, which means they drink less, right? So that's why we can actually create this in a binomial system. So n is 180 because we're asking 180 people, or we've got 180 trials, and our p value is the probability that any one person drinks more than 2 litres, which is 0.35. So using these numbers, what we actually get for this, you could put this in your calculator and get 0.5847. Okay, so the probability that between 60 and 70 out of the 180 people to drink more than 2 litres of water a day is 0.5847. Okay, then so that takes care of this bit here. Now we're looking for the probability that x is less than or equal to 70. All right, so we can change all of these values. Our lower this time is 0, right? Because the lowest possible number of people who don't drink 2 liters is 0, right? So 0, upper is 70, N is still 180, we're still asking 180 people, and P is still 0.35 because we still have the same amount of probability that each person will drink 2 liters. So after this, after putting this into our CAS, what we get is 0.8789, which means we now have these two values. So we can say that this, because this is this, and this is this. So that means that we can say 0.5847 divided by 0.8789, and that's going to be our answer. So that will be 0.6653, which is our answer D. So the reality is that the probability that x is greater than or equal to 60, given that x is less than or equal to 70, is the same as this, right? Because we've linked an x value and a p hat value because of this p hat equals x over n. So this is our biggest thing here. As soon as you see p hat, change it to an x value like I've done in this question here. So guys, 0.6653 is our final answer for MM387. If you have any questions about it, just hit me up in the comments below. But otherwise, thank you for watching as always, and I'll see you in the next video.